Okay, so we're all online like all the time these days, right?
Yeah.
But I
Yeah.
feel like most of us never really think about like how it all works. How does stuff just like magically get from my phone to like someone else's computer on the other side of the world?
It's true. We just kind of take it for granted. But there's a ton of like really complicated engineering that makes it all happen.
Right.
And one of the big pieces of the puzzle is uh, the way the internet itself is structured, something called network topology.
Network topology. Sounds a little intimidating, honestly.
I know it sounds kind of techy, but it's actually not that bad. It's just a way of describing like how all the devices are connected and how data moves between them.
So it's like a roadmap for information, like traveling through the internet.
Exactly.
Yeah.
And like we got this awesome fundamentals of cybersecurity lecture PDF we're diving into today. And it turns out
Oh, cool.
these networks, they come in all these different shapes. Like some are called stars, others are meshes, and it all makes a huge difference in how the network actually like functions.
Wait, so you're saying it's not just about plugging things in, the shape of the network actually matters.
Totally. The shape determines how data flows, which affects
Right.
everything from speed to security. Even things like how easy it is to add more devices or how vulnerable it is to failures. It all depends on the shape.
That's so wild. I'm already thinking about like my Wi-Fi setup at home. Like, does that have a shape?
It totally does. We'll
Yeah.
get into that. But first, let's break down the basics.
Okay, I'm ready.
So you got to understand two.
Oh, okay. So that's the physical network, the actual like layout. But what about the logical side then?
Think about the traffic patterns on those roads.
Okay.
That's your logical topology. It's all about how data flows through that physical structure.
I see. So even if the roads stay the same, the traffic can change, right? Like
Yeah.
rush hour versus, late at night.
Exactly. And just like traffic can be routed different ways, data can take different paths through the network
Mm,
depending on the logical topology.
that makes sense. Different routes for our data. And hey, speaking of routes, like roads, I remember way back when I was learning about different kinds of internet cables. Did those play a role in all this?
For sure. The type of cable used for those physical links, it makes a big difference in terms of speed and reliability. You've got your coaxial cables, twisted pair cables, and then there's fiber optic, which is like
Yeah.
the superhighway of data transmission.
Fiber optic. Yeah, I know that's like crazy fast. But like, why? What makes it so much better?
It's honestly kind of mind-blowing. Fiber optic cables use pulses of light to transmit data. That's how you get those blazing fast speeds and way more bandwidth in with those old copper cables.
No way. So it's literally light zipping through those cables. That's way cooler than just electrical signals.
Hmm.
Okay, so we've got our nodes, our links, and our different road types, like coax versus fiber optic. Now, I'm really curious about these network shapes, these, what was it, topologies. Like, what are some of the common ones out there?
All right, let's start simple point to point. It's exactly what it sounds like.
Right.
A direct connection between just two nodes. Think like a dedicated phone line between two offices.
Ah, okay. Simple and straightforward. But I'm guessing that doesn't really work if you've got a lot of devices, right?
Not really. Things get more complex when you've got more than a handful of devices. That's where topologies like bus, ring, star, and mesh come in. Each one connects devices in a different way and has its pros and cons depending on what you're trying to do with the network.
Okay, I'm ready to dive into those shapes and see what's what. Let's start with bus topology. That one sounds interesting.
All right, picture this. A single cable running along like a main highway, and all the devices are connected to it like on-ramps.
Okay.
It's simple, pretty cheap, especially for a smaller network.
But wouldn't everyone be fighting for space on that one highway? Like, wouldn't things get backed up?
That's one of the downsides, yeah. You can get data collisions when multiple devices try to send data at the same time, which slows everything down. And if that main cable goes down, the whole network's toast. It's like a massive traffic jam.
Yikes. Okay. So not the most robust option. What about this ring topology then? Does that one improve things?
For sure. Imagine a circle of devices, each connected to its two neighbors. Data flows around the ring like cars on a racetrack.
Okay, I can picture that.
The cool thing is if one part of the ring fails, data can just reroute in the other direction.
Oh, so it's like having a backup route in case of a road closure. That's smart.
Right. And that's why ring topologies are used a lot when you absolutely need the network to stay up and running, like 24/7. And there's also this thing called dual ring, which is even more reliable.
Dual ring. Okay, what's that? Two rings.
Yeah, basically two rings sending data in opposite directions. If one fails, the other one keeps things going smoothly. It's like having a backup generator for your network.
Wow, so that's like The ultimate in reliability. But I'm guessing those dual rings are also super complicated,
They
right?
can be, yeah. What about something a bit simpler like star topology? That's probably what you've got for your Wi-Fi at home.
Oh, yeah, probably. I have a router, and everything connects to that. So is that the star shape?
Yep. Star topology is super common for homes and offices. You have that central hub, your router, and all the devices connect directly to it, like spokes on a wheel.
So each device has its own lane to the router.
Uh,
That seems like it would be faster than sharing a single cable, like in that bus thing.
It is, and it's more reliable, too. If one device goes down, the rest of the network is fine. It's like having a separate road for each car to get to the city center.
Hmm.
But there's a catch. If that central hub, your router, fails, everything goes down with it.
Ah, so it's like putting all your eggs in one basket. Kind of risky. Gotcha. Okay, what about this tree topology I see here? Kind of sounds like a family tree, branches coming out from a central trunk.
You're spot on. It's like a mix of star and bus. Think of a central hub with several smaller star networks branching out from it.
So, like a company with a main office and several branch offices, each with their own little network.
Exactly. It lets you scale things up and organize the network in a hierarchy. But same problem as a star. If that central hub goes down, the whole tree falls.
Okay, starting to notice a theme here. A lot of these have a single point of failure that can take down the whole thing. Is there any way around that?
That's where the mesh topology comes in. This is where it gets really cool. Instead of relying on a central hub, each device in a mesh network is connected to at least one other node. So you create multiple paths for data to travel.
Oh, wow. So it's like a spider web or something where everything is interconnected. That sounds super resilient.
It is, and because data can take multiple routes, it's really fast and efficient too. There are two main types of mesh networks: full mesh and partial mesh.
Okay.
In a full mesh, every device is connected to every other device.
Whoa, that's like ultimate connection, but I bet that's also super complicated to set up, especially if you have like tons of devices.
Yep, full mesh gives you incredible redundancy and speed, but it's definitely expensive and tricky to manage. Partial mesh is a bit more realistic. Some devices have direct connections, while others relay data through intermediary nodes.
So partial mesh is kind of a compromise, like a good balance between being super resilient and, super complex.
Got it.
Hmm.
Are there any other topologies we should know about? There's also hybrid topology, which is basically mixing and matching. You take elements from different topologies and create a custom solution.
Oh, interesting. So it's like designing a network with different types of roads, bridges, tunnels, whatever works best for the situation.
Exactly. But that obviously takes careful planning. You have to think about the size of the network, the type of data, security, and of course, budget. Choosing the right topology is key to building a network that actually fits your needs.
This is all making a lot more sense now. But even with the right shape, are there other things that can affect how well a network actually works? Like, besides just the topology itself?
Oh, definitely. There are other factors that come into play like network latency, efficiency, resilience, security, scalability, and even just maintenance costs. All of those things can impact network performance.
Whoa, okay, so there's even more to this than I thought. Let's break down some of those other factors a bit more. Starting with network latency, what exactly is that? And, like, why should we care about it?
Network latency is basically the delay between when you send a request and when you get a response. Like you click a link and it takes a few seconds for the page to load. That's latency.
Oh, okay, so that's why my video calls sometimes lag or my online games freeze up. It's high latency messing things up.
Exactly. And it's measured in milliseconds, so even small differences can have a big impact, especially for things like video calls, gaming, or financial transactions, where speed is super important.
Got it. So low latency is good, high latency is bad. What about efficiency then? How does that factor into all this?
Efficiency is all about how well the network uses its available resources. A well-designed network, it minimizes bottlenecks and keeps data flowing smoothly without unnecessary delays. Think of it like a well-organized transportation system. You want to avoid traffic jams and make sure things get where they need to go quickly.
Right, like a smooth running machine. And what about resilience? We talked about how some topologies, like those ring and mesh networks, are more resilient to failures. But what else can you do to make a network better at bouncing back from problems?
Redundancy is key. Having multiple paths for data, backup systems, and strong security measures are all crucial for building a network that can handle disruptions. Like, imagine a city with multiple bridges and tunnels. If one route gets blocked, there are other ways to get around. Same idea with networks.
Okay, so it's all about having a backup plan. What about security? I mean, with all the data breaches and cyber attacks we hear about these days, how does network topology affect security?
Security is super important. You need to protect the data traveling through the network from unauthorized access, snooping, and tampering. The topology you choose can definitely impact your security. Like a bus topology, where everyone's sharing the same cable, that's way less secure than a star topology, where each device has its own dedicated connection to the central hub.
Oh, that makes sense. So the shape of the network can actually make it easier or harder for, hackers to get into the system. What about scalability? We touched on that before, but why is it important for a network to be scalable?
Scalability means you can easily add more devices and users to the network without sacrificing performance. Like as your needs grow, you don't want to have to completely redesign your network every time you add a new computer or device.
Makes sense. You want it to grow with you.
Exactly. A scalable network can handle growth without any major disruptions.
That's super important for businesses, right? Like companies that are always expanding and adding new people. Okay, last but not least, let's talk money. Building and maintaining a network can be pricey. How does topology play into the cost?
Cost is always a factor, and different topologies come with different price tags. Like a simple bus topology might be cheaper to set up initially, but it could cost more in the long run because it's not as reliable or secure. A mesh network might be more expensive up front, but its resilience and efficiency could save you money down the road.
So it's like making an investment, you have to think about the long-term costs and benefits, not just the initial price. Speaking of things we invest a lot of time in, let's talk about social media. It's like we all use it every day and it totally relies on networks, right?
Social media is a perfect example of how network topology affects our daily lives. Think about all the data flying around when you're liking posts, sharing photos, sending messages. You need a network that can handle that kind of traffic. And then there are all the security implications of all that data being stored online.
Wow. Yeah. We've talked about all these different shapes and stuff, but now I'm really curious about how they're actually used in the real world, especially with something as big as social media. Like, what's going on behind the scenes of our favorite apps?
Great question. We'll dive into that next. We'll explore the networks behind platforms like Facebook, Instagram, Twitter, TikTok. And we'll talk about the privacy and security implications of all that data being shared and stored online. This is where it gets really interesting.
Okay, I am so ready for this, but first, I need another sip of coffee.
Game here.
All right, so we're back, ready to go deeper into this whole social media thing. I gotta say, I'm already looking at my apps a little differently, thinking about all those networks behind them.
So like once you see it, you can't unsee it.
Like,
Like, when you learn to drive and suddenly you're super aware of all the traffic lights and signs. You were using them all along, but now you understand how it all works. And the systems behind social media, they're huge, complex. They have to handle an insane amount of data, like from millions, even billions of people.
yeah, it's kind of crazy when you think about it. Every comment, every
Yeah.
photo, it's all zipping around the internet through those nodes and links and whatever. I'm guessing they don't use that simple bus topology we talked about for all that traffic.
You're catching on quick. Social media platforms need super robust, sophisticated network architectures. Remember we talked about those mesh networks with all those interconnected nodes and multiple paths for data.
Yeah, like that spider web thing.
Right. Those are crucial for handling the sheer volume and speed of social media. All those interactions happening all the time.
Makes sense. You want those cat videos and news updates and stuff to load instantly, no matter how many people are online at the same time. But what about the social media companies themselves? Like, how do they choose which network topology to use? Do they, build their own giant data centers, or do they rent space from, Google or Amazon or something?
That's a good question. And it's actually a mix of both. Some platforms, especially the bigger ones, they do build and manage their own data centers. That gives them a lot of control over their infrastructure, their security. But others, they opt for those cloud-based solutions. They rent server space and computing power from, like Amazon Web Services or Google Cloud.
Yeah.
It all depends on how big they are, their budget, how much control they want to maintain.
So it's kind of like deciding whether to buy a house or rent an apartment. Owning gives you more control, but renting can be more flexible, maybe more affordable.
Okay, so now I'm picturing these massive data centers
Yeah.
with servers humming away, all connected in this crazy mesh network, handling all those social media requests. But what about my data? Where does that go? And how do they keep it safe?
That's a super important question, and it gets to the heart of data privacy and security. When you make a profile on social media, you're basically trusting them with your personal info. And the details are going to be different on every platform, but they're all collecting data about what you do, what you're interested in, even your location.
Yeah, I always just kind of like skim over those privacy policies, all that legal jargon. But now I'm thinking, maybe I should have paid more attention. It's kind of creepy to think about all that data, like just sitting out there somewhere. Someone could be analyzing it, using it in ways I don't even know about. That's why it's really worth taking the time to like actually understand what you're sharing and how it could be used. Some platforms are definitely better than others about being transparent about their data practices. Look for stuff like data encryption, strong password policies, that two-factor authentication thing, which adds an extra layer of security to your account.
Right, right.
And be careful about apps that ask for like a ton of permissions, access to your contacts or location data.
Hmm.
Do you really want them to have all that?
It's like inviting someone into your house. Right. You want to be careful who you trust, what you give them access to. So, apart from those big data breaches, which are obviously a huge concern, what are some of the other risks with social media? We've all heard about like cyberbullying, scams, fake news, all that stuff, but how does the network topology play into those problems?
Network topology itself doesn't directly cause those problems, but it can affect how easy they are to deal with. Like a decentralized network, something like a mesh, that can actually make it harder for one single entity to control information or censor stuff. But then a centralized network that can make it easier to track down like bad actors or remove harmful content.
Hmm. So it's kind of like comparing like a public park to a private club. The park is open to everyone. That's great for like free speech and stuff, but it's also harder to, control what people do there. The club, it has more rules, more restrictions, but it can also be a safer, more controlled environment.
That's a great analogy. The design of the network really shapes how information flows, how people interact, and ultimately how safe and healthy that online community is.
It's like we're the architects of this digital world, right? We build the spaces where people connect and communicate. And with great power comes great responsibility. We need to think about the ethical side of the networks we're creating.
100%. We have a responsibility to design networks that aren't just efficient and reliable,
Yeah.
but also safe, inclusive, respectful of people's privacy and their right to make their own choices.
I love that. Building networks with like integrity, networks that empower people, not exploit them. It's exciting to think we can use this knowledge about network topology to make the online world a better place. But, let's be real, there's still a ton of challenges and risks with social media. What are some things our listeners should keep in mind as they're like scrolling through their feeds?
Just be mindful of the information you're sharing, both publicly and privately. Think about your privacy settings. Be careful about who you connect with. Don't believe everything you see online. Double check before you share something. And honestly, the most important thing, remember that the online world is just one part of your life. Don't let it consume you. Don't let it determine your self-worth.
That's so true. It's so easy to get caught up in comparing ourselves to others, chasing those likes and followers. But we have to remember, it's just a network, just a tool. Keeping that in mind helps us keep things in perspective.
Absolutely. And by understanding how these networks work, we can be more informed and empowered users.
So we've gone from like payables and nodes and all that techie stuff to like the big picture social and ethical implications of social media. But I still have one more question. We've talked about networks online in the digital world. What about in real life? Are there network topologies at play in our everyday lives, like offline?
That's a great question, and the answer is absolutely yes. Network topologies aren't just for computers and data. They're everywhere. Think about transportation systems, power grids, even the flow of information within a company or an organization. It's all about connections, how they shape the flow of, well, anything, really data, electricity, people, even ideas.
Wow, that's blowing my mind a little bit. Now I'm starting to see network topologies everywhere, the roads we drive on, power lines, even the relationships we have with like friends and family. It's all interconnected in ways I never even thought about before.
It's pretty amazing when you start to see it, right?
Yeah, it really is.
The world is this web of interconnected systems, and network topology is like the key to understanding how they work, how they affect us.
So, as we wrap up this deep dive, I want to leave our listeners with a little challenge. Look around you. What networks do you see at play in your daily life? How are they shaped and how do they affect your experiences?
And how could you make those networks better, more efficient, more resilient, more beneficial for everyone?
That's a great challenge. It's time to put our newfound knowledge to work and see the world through a whole new lens, the lens of network topology.
Exactly. And who knows, maybe you'll even find ways to improve those networks, make them work better for everyone.
We've gone from like invisible cables to city layouts to the social media feeds we scroll every day. It's like network topology is the secret code underlying so much of modern life.
It really is. And once you start seeing it, you can't unsee it. It's a powerful framework for understanding how things work, how they connect, and how they can be improved.
You know, thinking about these networks in the real world, it makes me wonder about their history. Like, did someone just wake up one day and say, hey, let's connect everything in a star shape? Or did it evolve over time?
It's a fascinating story of evolution and innovation. Early networks were limited by technology and cost. So simple topologies like point-to-point or bus, those were common. But as computing power got better and the need for faster, more reliable connections grew, new topologies emerged.
So the internet as we know it today, it wasn't built overnight. It was a gradual process, like trial and error, refining things as they went. Kind of like how cities evolve, right? New roads get built, infrastructure changes as the population grows and needs change.
Exactly. And networks, just like cities, they face challenges of scalability, efficiency, and resilience. They need to adapt to new demands, new technologies, and they need to be able to withstand disruptions. It's a constant process of, like, tweaking and optimizing.
Okay, so understanding network topology isn't just for tech experts. It's a useful skill for anyone, right? Whether you're building a website, designing a transportation system, or even just like organizing a team at work.
For sure. It's a way of thinking, a framework for understanding how things are connected and how those connections affect behavior and outcomes.
I feel like we've covered a lot of ground today, going from those basic building blocks of nodes and links to the complex networks behind social media and even those real-world systems. I personally feel like I've gained a whole new understanding of how the world works.
Me too. And hopefully a new appreciation for how important network topology is in shaping our lives. I mean, we're more connected than ever these days.
Absolutely. So, as we wrap up this deep dive, I want to encourage our listeners to keep exploring, keep asking questions, keep looking for those hidden networks all around you.
Because once you start seeing the world through the lens of network topology, you'll never look at it the same way again.
That's such a great point. Thanks for joining us on this journey into the fascinating world of network topology. Until next time, happy networking.
We've gone from like invisible cables to city layouts to the social media feeds we scroll every day. It's like network topology is this secret code underlying so much of modern life.
It really is. And once you start seeing it, you can't unsee it. It's a powerful framework for understanding how things work, how they connect, and how they can be improved.
You know, thinking about these networks in the real world, it makes me wonder about their history. Like, did someone just wake up one day and say, hey, let's connect everything in a star shape? Or did it evolve over time? It's a fascinating story of, well, evolution and innovation, really. Early networks were pretty limited by the technology at the time, and cost was a big factor too. So simple topologies like, point-to-point or bus, those are the most common. But as computing power increased and the need for faster, more reliable connections grew, well, new topologies emerged.
So the internet as we know it today, it wasn't built overnight. It was a gradual process, like trial and error, refining things as they went. Kind of like how cities evolve, right? New roads get built, infrastructure changes as the population grows and needs change.
Exactly. And networks, just like cities, they face challenges of scalability, efficiency, and resilience. They need to adapt to new demands, new technologies, and they need to be able to withstand disruptions. It's a constant process of like tweaking and optimizing.
Okay, so understanding network topology isn't just for tech experts. It's a useful skill for anyone, right? Whether you're building a website, designing a transportation system, or even just like organizing a team at work.
Absolutely. It's a way of thinking, a framework for understanding how things are connected and how those connections affect, behavior and outcomes.
I feel like we've covered a lot of ground today, going from those basic building blocks of nodes and links to the complex networks behind social media and even those real-world systems. I personally feel like I've gained a whole new understanding of how the world works.
I think so too, yeah. And hopefully a new appreciation for how important network topology is in shaping our lives. I mean, we're more connected than ever these days.
Absolutely. So as we wrap up this deep dive, I want to encourage our listeners to keep exploring, keep asking questions, keep looking for those hidden networks all around you.
Because once you start seeing the world through the lens of network topology, you'll never look at it the same way again. It changes everything.
That's such a great point. Thanks for joining us on this journey into the fascinating world of network topology. Until next time, happy networking.